Welcome. This is section 2 of solution 2 in CSE 239, Scientific Computing Applications. I'm Professor Timothy Kentop. Picking up where we left off from section 1, the first thing we'll want to do is clear the screen. So we're going to enter the clear command in our terminal prompt, being sure we've captured this screen for our Word document for section 1. I'm going to clear this, and what we're going to do in section 2 has to do with manipulating or munging data using cut, paste, join, and more elegant ways of viewing data. We're going to use cat to create content, not just to view it. That's the first step of the process. So we're going to create a simple data file called testfile.out. The quick brown fox jumped over the lazy dog. This is on page 18, section 2.3.8, and we're going to include 10 numbered blank lines, and then we're going to press Control D to get out of that. So cat, and then my redirect testfile.out. So we're using cat, but this time with a redirect symbol, and that's going to put our terminal into kind of an editing mode. And I'm going to type the quick brown fox jumped over the lazy dog. I'm going to hit the return. In your book it shows some angle brackets. You're not typing the angle brackets, you're just pressing return wherever you see CR in angle brackets. I'm going to enter 1 for the first line, press return, 2 for the first line, or CR, carriage return, 3, 4, 5, 6, 7, 8, 9, and 10. On this last line, below the blank line 10, I'm going to press the Control key, hold it down, and tap D. And it's going to get me out of edit mode. And so if I look at my directory now, I should see testfile.out. One of the cool things about the head and tail command is that I can see the first 10 or the last 10 lines of a data file. And this can be very helpful because you get a chance to catch a glimpse of how a file begins or ends. You're using tail whenever you're appending data to a file. You want to see the last thing that was appended to the file. You use head if you want to see specifics about the header of the file and its identity and purpose and so on. So both have its place. Once again, you'd use tail more often when you're appending data to the end of a file. You'd see the last 10 lines of a file to see if it appended properly. That's the intent of a tail. So what we want to do is just see how this works. And we're going to issue both of those commands with testfile.out to see if we get the same result as the textbook. So if we start with head first, and then testfile.out, testfile.out, you see that the 10th line is not displayed. The first line of text is actually the first physical line of the file, and then 1 through 9 are the next 9 lines, and then it stops. You don't see 10. Let's try tail. I'm going to repeat this, but I'm going to use my left arrow key to replace head, backspace over head now, and put tail, and hit enter. Now you see the same result that we have in the textbook. The first line of text is missing, but all of the numbered lines 1 through 10 are showing. And this produces exactly the same example that's found in 2.3.8 of your textbook. You want a screenshot of this here, and you want to paste that into section 2. That's your first artifact in section 2, showing that you've done this. and then we'll be on with the other examples. Next, we're going to create two data files that are shown in section 2.3.23, cutting, pasting, and joining. And they're two very simple files, one with letters, the first one, A, B, and then the second line C, D, and E, F, with a space in between. And then in B.dat, there are 8 numbers, with 4 numbers in the first row and 4 numbers in the second row, 1 through 4 in the first row, 5 through 8 in the second row, with spaces in between. Exactly what's shown on page 30 and 31 of your book. We want to do that using cat, the same command we did previously. So we're going to issue the command cat and then redirect output to a.dat. And we're going to type A space B. Whoops. All right, let's oops, up arrow key doesn't work. I'm going to press Control D and start over again. So I'm going to remove the file a.dat that I just did, so I can start over again. And I'll go ahead and repeat the command. And then A, got a little fast for myself there, and just put A on the first line. A space B, enter. C space D, enter. And then E space F, enter. And at that point, we'll Control D. So if I cat a.dat to see what it is, I have the same file in the textbook on the bottom of page 30. Now I'm going to do the same thing for b.dat. I'll go ahead and redirect to B this time to create it. Only now we're using numbers. I'm going to use 1 space, 2 space, 3 space, 4 space, enter, 5 space, 6 space, 7 space, 8 space, enter, Control D. And now if I look at the file just to be sure it's correct and it matches what's in the textbook, there it is. So I have A, B, C, D, E, F, and 1, 2, 3, 4, 5, 6, 7, 8, and they're arranged differently. We can use the paste command to stitch the contents of b.dat onto the right side of the a.dat file. Put another way, we can stitch the numbers onto the right side of the letters by using paste. And then we can also create a third file using redirect. So I'm going to do that first, though, just to demonstrate. Paste a.dat and b.dat. And what that gives us is the result that you see in your textbook. What we want to do now is go ahead and redirect this to a file called c.dat. So we'll repeat the same command, but this time, after the last part of this, we're going to use the redirect command and then put c.dat. And that's going to take the same output you see on the screen, only enter that into the third data file, c.dat. So let's look and see if c.dat did what it was supposed to do. And yes, it does. Now you'll notice there's a difference in each of these files by the spaces in between the characters. And it could be that we have to create these without having an extra line at the end of each data file. Put another way, after F I hit return, and then instead of hitting return immediately after F. So I'm going to go ahead and take a moment just to see if that makes a difference. We want our output to look exactly like what's in the textbook. Please stand by. Here you see there's no difference in the output and how it's displayed in the screen, whether we have an extra line at the end of A, B, C, D, E, F, and whether we have an extra line at the end of the numbers in B dot dat. So either approach is going to produce the same output. It'll be interesting to see if the next example the book reviews produces the same output. Please stand by. So here we're using the cut command. Based on the example in the book, we're going to identify the delimiter as a space, and we're going to use the b.dat, the numbers, and we're going to go ahead and focus on the second and third columns. What we want to do is see if d.dat looks just like the results we see after we use the paste command again. So we're going to hit execute at this point. We're going to hit enter. And the command took. It's successful. So now we're going to paste d.dat to a.dat, and we should get the same result that we had that shows at the bottom of page 31 in your book. So I'm pasting d.dat to a.dat, and what I should see are 2, 3, 6, 7, A, B, C, D, E, F. And I do. There's just additional spaces in there. So that's the only difference. At this point, what you want to do is, and I'm hoping at this point what's hitting is this reality. Many of us have the misguided notion or misconception that you have to have fancy database software to manipulate data elements in data files. And this is a very common and it's a prevailing idea. And what's really elegant about the Linux platform as a scientific computing applications platform is that it gives you the tools to work with data files so that you can manipulate or munge them. So munging the files is a term we discussed earlier, and it's important to understand what that term means. You have to be able to manipulate data and cut and paste and join them. That's the last example we're going to do. So we aren't going to take a screenshot yet. We're going to use the join example in just a moment so you can see where we take this. So join is the last of the three commands. Cut, paste, and join. We want to give you an example of join. To complete the example with join, we need to create two more data files. We're going to call these data files midterm.dat and final.dat, and they're going to be constructed exactly as shown on page 32, with a space between the student ID, the notional student ID, the 3-digit student ID, and the 2-digit score, raw score, for the midterm and final data. I'll go ahead and do that here, and then I'll pause the recording, but you'll see the finished result in just a moment. So here you see I've created two data files, one called midterm.dat, and I did use a slightly different convention than the book. So student 123 had a midterm score of 23. Student 456, instead of 234, had a midterm score of 25, and student 789 had a midterm score of 33. For the final.dat, we have student 123 received an 83, student 456 a 75, and student 789 a 97. We're going to use the join command to join midterm.dat and final.dat into allgrades.dat. And then we're going to display allgrades.dat with the cat command. And what we should see is that it combined the scores without repeating the student IDs. So it's going to basically append the final scores after the midterm scores to create a basic data table. This is a really important technique, and it's very helpful. All right, so first, join midterm .dat to final .dat, and we're going to redirect that to all grades .dat. And now we're going to review what's in all grades.dat. And what you see here is exactly what's shown in the book. You see that it combined or stitched or joined the two data sets to create a single data set. It joined the results. This is all done without SQL or without fancy database applications. Very powerful. At this point, what we want is for you to highlight this last section, take a screenshot, and then paste this into your Word document. This concludes section 2 of solution 2.